Welcome back, class, to chapter 6.7, graph linear equations in two variables. And today we're going to go back, kind of revisit graphing all in general, with using inequalities now. So kind of look at this definition, and as we're going through the video, it will make more sense to you. But the linear equation in two variables, such as x minus 3y is less than 6, is a result of replacing the equal sign in a linear equation. So what they're saying here is we're used to seeing this, an equal sign, a linear equation right there. So we're replacing that sign with any of the inequality signs. A solution of any inequality in two variables x and y is an ordered pair x and y that produces a true statement when the values of x and y are substituted into the inequality. So meaning we're going to plug in an inequality, we're going to plug in an ordered pair, for example 0, 0, in for x and in for y, and we're going to see if this statement is true. So that's what it says, a true statement when the values of x and y are substituted into the inequality. So here's an example. We have x minus 3y is less than 6. Check whether the ordered pairs is a solution of the inequality. So that's just replacing. So we would say x minus 3y is less than 6. So substitute that in. Well, x is 0 and our y is 0. Here's our x and here's our y. So I substitute that in. 0 minus 3 times 0 is less than 6. And 0 is less than 6. So is that a true statement? Yes, that is true. 0 is less than 6. So plug in 6 and negative 1. Remember, this is our x and this is our y. So x minus 3y is less than 6. So we have 6 minus 3 times a negative 1, which is less than 6. Well, we know that negative 3 times negative 1 is a positive 3. So 9 is less than 6. Is 9 less than 6? That does not work out. So you'll see later it's going to come together, and you'll see why it's very important that you check an ordered pair with your linear inequality equation. Okay, so you'll be given in your homework tomorrow, an inequality equation similar to this one right here we had with an ordered pair, and you'll have to check whether it makes the statement true or false. So now, graphing a linear inequality in two variables. So graphing now. So the first thing is to graph the boundary line, and we'll talk about what that is. But the main thing is when you graph this boundary line, you use a dashed line for less than or greater than, and use a solid line for greater than or equal to or less than or equal to. And I'll explain that more when we graph. Test a point not on the boundary line. So when we draw this boundary line, we're going to test a point. And then we're going to shade the half of the plane containing that point if the ordered pair is a solution of the inequality, or shade the other half of the plane if the ordered pair is not a solution. So it'll make more sense once we do a problem. So let's look at this problem we have. Y is greater than 4x minus 3. So the first thing is we're going back to graphing. Okay, we're used to seeing it as 4x minus 3. So going back to graphing, we're going to graph this line. Now, step 1, okay, you're going to identify whether we're going to have a shaded line or a dotted line on our boundary line. So because it's a greater than sign and it's not an equal to, greater than or equal to, it's just greater than, it's going to be a dashed line. Okay? So we know it's going to be a dashed line. So now let's graph y equals 4x minus 3. So we go to negative 3 because that's our b, that's our y-intercept. And then we're going to go up 4 over 1 because that's our slope. Okay? You really only need to make 2, but I'll make another one just in case. 1, 2 over 1. Okay? So here's our line. And I said it's going to be a dashed line because it's not equal to. Now, the dash means that even if you pick a point on this line, it will not make this equation true. this inequality. equation true. Okay? So, step one, we drew the line, we graphed the line, and we made it a dashed line because it's not an equal to, it's just greater than. So step two is asking us to test a point. Well, the point that I would always pick is 0, 0. I think it's easiest. Okay, unless our line goes through that point and tells us we can't use it. Okay, this line does not go through 0, 0, so let's use 0, 0. So we're going back to the first problem we worked on, and we're going to see if the statement is true or false. Okay, so 0 is greater than, well, we know they cancel out, -3. Is 0 greater than -3? Yes. So step 3 says, if the statement is true with the point you picked, you shade that side. So we know that this is true, so we're going to shade that side. So any point that's not on the line but to the left of this line will make that statement true. And we can prove that just on this problem alone. I'll prove it to you. So let's say we chose, 0, 1. 0, 1 is right in this area right here. Okay? So it should make the statement true. So is 0, no, I'm sorry. 1 is greater than 4 times 0 minus 3. Well, is 1 greater than -3? That is true. Now, let's pick a point like here. 2, 0. So, 0 is greater than 4 times 2 minus 3. Is 0 greater than 8 minus 3, which is 5? Is 0 greater than 5? Nope, that does not work out. So you see that that is not in our shaded region right there. Okay? So now, what step 3 also says is, if 0, 0 was false, if this point was false, if it didn't work out, then we would shade this side over here. If it didn't work out, but it worked out, so we have to shade the side that it's on. So let's try it again. So x plus 2y is less than or equal to 0. First thing that I would do is I would get this into y equals mx plus b form. Okay, remember, y equals mx plus b form, slope-intercept form, we can graph. So we know that this is x plus 2y, and I'm going to put it as equals sign right now. I'm going to subtract the x. 2y equals -x. Divide by 2. Y equals -1/2 x. Okay, plus 0, or b is 0. So this tells me that we're going to have to start at the 0, 0 mark here. So what this is really saying is y is less than or equal to -1/2 x. So we'll start at 0, 0 here. We're going to go down 1 over 2. Down 1 over 2. Okay, up 1 over 2 this way. Now, it's a equal to sign, so it's not a dash line. Remember, step 1, we're determining our boundary line. This is our boundary line. It can be equal to, so there we go. That's our line. It's a solid line because of this equal sign right here. Very important. So let's choose a point. So it's on 0, 0. So we got to pick a point that's not on the line. So let's choose 0, 2. So 0 plus 2 times 2 is less than or equal to 0. Well, we know 0 plus 4 is less than or equal to 0. So 4 is less than or equal to 0. Is 4 less than or equal to 0? No, it is not. So we know that we will shade this side. Okay? The point that I picked did not make that statement true. So I chose this point here. It did not make that true, so we're going to shade the bottom side of that. So if you wanted to check it, plug in, let's say, plug in -1, 0. So -1 plus 2 times 0 is less than or equal to 0. That cancels out, so negative 1 is less than or equal to 0. Is negative 1 less than or equal to 0? Yes. So we know we shaded the correct side here. Alright, so again, step 1, set it equal to y equals mx plus b form. Graph it. Figure out if you have a dashed line or a solid line. Okay, then choose a point in step 2. Solve it algebraically to see if it makes sense or not. And then shade the side if it does make sense, and if it doesn't, you shade the other side. So now we have y is greater than or equal to 3 and x is less than negative 1. You know if the equation does not include an x, it's going to be a special line. And if it doesn't include a y, it's going to be a special line. Okay? So y is greater than or equal to 3. These ones are a little bit easier than when you have a equation that has like y equals mx plus b. So what we're going to do is go pretend that this is y equals 3 first. So go to y equals 3. And we know when it's y equals 3, it's a horizontal line. Sorry, it should be a straight line. Sorry about that. And then we just read it. It says y is greater than or equal to 3. So remember, it's a solid line because it's equal to, and y is greater than. So where is y greater than? Well, that's above the line. So we can shade above it. And you can try it. Plug in 1 here. Is 1 greater than or equal to 3? No. So we're not shading anything down here. Sorry about my cold I have going on right now. X is less than negative 1. Okay, remember, x is equal to negative 1. We go to negative 1. We know that this is a dashed vertical line now because it's not equal to. And y is less than negative 1. So what is less than? Negative 2 is less than negative 1. So we shade the left side of here. Okay. So just on the ones that don't include an x, or this one doesn't include a y, you know that they're going to be a special line. Okay, here's your homework. Graph the inequalities. Okay, so make a separate coordinate plane for each one of these. Make sure it's in y equals mx plus b form first before you draw that boundary line. Look at the problem whether it should be a solid boundary line or it should be a dashed one, and then choose a point to see whether you should shade within that point or on the opposite side of that boundary line. Well, if you have any other questions, please feel free to email me tonight. If I don't hear from you, then I'll see you tomorrow in class, or Thursday actually. I'll see you Thursday. Take care.